Hi, my name is Zola, and we are at week 5 in Cloud and Beyond. So, for this week, I've been tasked to summarize 3 articles on cloud computing. So, each one comes from a different perspective at a different time. So, together, they gave us a really complete picture of how cloud evolved. The first one is from InfoWorld magazine from April 2008, so it's an industry publication. The second one is an academic paper from Rochester Institute of Technology, also from 2008. And the third one is the IEEE engineering paper from 2012. So 4 years later than what cloud has been deployed at scale. So what useful is that each article answers a different question. So InfoWorld asks what is cloud computing, RIT asks how does it work, and IEEE asks how do we actually build and deploy it, and what did we learn. So let's start from the InfoWord article. So to understand why this article mattered, you need to know how confused the industry was in 2008. So Gartner senior analyst Ben Pring said that cloud computing had become the phrase du jour, meaning that everyone was using the term, but nobody agreed on what it meant. So it's so confusing for them at that time. So on the other side, you had a narrow definition which means a cloud is just a virtual servers available over the internet. It's very technical and very limited, but the other side, the broad definition, it says that anything outside your firewall is cloud. So by that logic, outsourcing is cloud computing, which obviously is not. So InfoWorld took a different approach. So instead of asking what technology is this, they asked what does IT actually need, and that changes everything. So here's what they came up with. Um, Cloud computing is any subscription based or pay per use service that in real time over the internet extends IT's existing capabilities without investing in new infrastructure, training new personnel, or licensing new software. So if you break it down, because every word actually matters, first one is subscription, so meaning that you don't own it, you just rent it. Second one is real time, which means it is delivered immediately. Third one is extend existing capability, so it can add to what you already have and it doesn't replace your whole system. Fourth one is there's no new infrastructure, training, and licensing. So that's a whole value proposition. So if you think of it like this, it's like electricity. So you don't ask what type of power generation runs your light, you just plug in and pay for what you use. So cloud works the same way. So with that definition in hand, InfoWord identified 7 categories of cloud services, and we need to walk through them quickly because it's a lot. First one is SaaS. So it's like a complete application delivered through the browser. Example of this is Salesforce. So everyone shares the same code base, and it's a multi-tenant architecture. So the provider maintains the app, so the costs stay low and the customer has zero upfront investment. Second is utility computing, meaning that the virtual service and storage are on demand. So yeah, so example of this is Amazon EC2 and 3 Tera. Next one is web services in the cloud. So these are the APIs. We all know what API is that API is like a bridge between different systems. It is used for one system to communicate to another system. So APIs only, so they're not like full application, but a specific functionalities. Some of these APIs are Google Maps or Bloomberg Data. So developers use these as building blocks. For one is the PaaS or the platform as a service. So development environments delivered as a service. Some of this Google App Engine. So everything that you have is pre-integrated. So you think of it as like building with Legos. So they provide you like the building blocks or the Legos, and you build it yourself. Next one is the managed service provider. So it's actually the oldest form of cloud. So applications exposed to IT teams, not end users. Example of this like security monitoring, like email virus scanning. Next one is the service commerce platform. This is like a hybrid of SaaS and MSP. So example of this like a travel booking or like expense management. And last one is the internet integration. So cloud services that connects other cloud services, but reminder that it is actually in early stages in 2008. So they don't have anything that could connect each cloud together. So in 2005, Grand Central tried it, but they failed because they were far too way ahead of the market. So there's just the insight here is that these seven functionalities are are not separate things. They are like variations on the same utility model. So basically, you don't own the infrastructure, you rent the services, you pay per use. So the only question is what level you're renting, the application, platforms, infrastructure, or specific functions. So this is by definitions of the info word. But here's a reality check since I have told you before that this is way before, it's like 2008. Cloud computing is not the unified cloud, it was more like sky computing, which means that there's a lot of isolated clouds floating around independently. So if you want Salesforce for customer relationship management, you got one cloud. If you want Amazon EC2 for your infrastructure, that's another cloud. If you want Google Apps for Office, that's a third cloud. So they don't interact and talk to each other. You have to plug into each one separately and manage them independently. So the vision was that eventually all these services will integrate. Orchestration buses will connect them, and there will be like a single management interface. But InfoWorld was realistic about this. They said that it is a long running trend with a far out horizon. So they said that among big meta trends, cloud computing is the hardest one to argue with in the long term, meaning that they got the direction, they know how to get from here to there, but the timeline is not connecting yet. And yeah, it's very old model, and there's like a bunch of technologies that came along before this. So let's see what's next. Since InfoWord told us what exists, now let's look at the academic perspective. So researchers at Rochester Institute of Technology were tackling a different problem. So the term cloud computing had only been coined in 2007. So the industry was extremely confused and there's no widely accepted definitions existed. Researchers from different backgrounds were approaching it to completely different angles. You got software engineers, different meaning into it entirely. You got database specialists that shows in it entirely. So Google Trends already showed cloud computing outpacing grid computing and search interest. That's on the RIT research. I just screenshotted the Google Trends. So RIT question was simple. Can we create a coherent framework for understanding cloud computing? So their goal was to define it properly, identify what makes it unique, explain the technologies behind it, and compare it to other computing paradigms like grid computing. Now, here's what they discovered. So cloud services aren't random categories. They are coherent three-layer stack. At the bottom or the layer one, we got hardware as a service, so virtual servers and computing resources on demand. So you pay as you go, like buying electricity. You pay for kilowatts used, or in this case, compute hours. So the key enabler here is the hardware virtualization. So multiple users share the same physical hardware. So in the middle, layer two, software as a service, application hosted and delivered over the internet. So the benefit is very obvious. You got no local installation, so user get application without managing deployment. Next one is the data as a service. Since data in various formats accessible via service. So the key is that you find data by logical name, not by physical location. So even though it is like geographically distributed, it still feels local. So now here where it gets out again. When you combine all three layers, hardware plus software plus data, you get what RIT calls infrastructure as a service. Sample of this the Google App Engine. So users don't think about three separate layers. They just get a computing platform that works. So this is powerful because it explains InfoWord fragmented seven categories that we have discussed earlier, and it shows how they actually fit together into a unified framework. Then RIT identified five features that distinguish cloud from other computing models. First one is user-centric interface. So the key thing here is that cloud is for everybody, not just for specialists. You don't need to learn how to code to make it work. So you just need to, it's very accessible for everybody actually. And on-demand service provisioning means that there's no demand, you can scale it instantly. And quality of service guaranteed, we got SLA. So service level agreement is what provider gives to you to outline what they are committing to provide you, such as performance, CPU, uptime. And if they fail to deliver, they got like penalties. So it shows accountability for your cloud provider. Next one is autonomous system. You don't need to manually automate everything. It consolidates automatically. And next one is scalability and flexibility. Already defined it as the most important one. Since cloud scales geographically, it can expand to new regions and it can scale by performance. So meaning you can upgrade your CPU or memory and you can start small and it eliminates upfront infrastructure costs. And we got RIT's five enabling technologies. At the foundation is the virtualization that we have learned the past few weeks. It is the bedrock of the entire cloud economics because it lets multiple users share the same physical hardware. On top of that, we got service orchestration and workflow. So what this means is that it just connects or organize automations into like one processes so it is smooth from end to end. Next one is the web services and SOA. So it actually means that different vendors can work together because they can speak the same languages. Next one is Web 2.0. It makes your web application very interactive and collaborative. So you call like rich UX UI design and you call like good interactive apps. The next one is distributed storage system. So data lives across multiple data centers in different location, but it feels like it's just in one place. So you get access by logical name, not physical location, because we all know that cloud regions are distributed everywhere to provide 100 or 99.9% availability or uptime. And now we go to IEEE. So we jump forward 4 years to 2012 and the IEEE perspective. So a lot have happened between 2008 and 2012. So in 2009, AWS grew into a real profitable business and Google launched cloud products. So in 2010, Microsoft Azure launched and thousands of companies started deploying it, and by 2011, cloud was mainstream. So the question shifted from if from the previous article of InfoWord to when on this IEEE article. So by 2012, there were like 4 years of real world production data. So IEEE researchers look at all this experience and ask what we have actually learned not theoretically but practically. So what works, what's the real architecture, what benefits did companies actually achieve, and what challenges did they actually face. Now, IEEE identified a four-layer architecture with a critical trait of at its core. I'm just gonna be quick about this since it has been discussed from previous weeks. But at the bottom, we got the server layer. So your provider manage everything here. That's the physical hardware, data centers, and network and users have zero involvement. Next one is the infrastructure as a service. You got virtual machine storage, networking resources. So the provider manage the physical hardware, but you manage the OS and application. And you got maximum control, but also a maximum responsibility. Next one is a platform as a service is for developer. So the provider manage the infrastructure plus the runtime, but you manage the code. Oh, sorry, that was platform as a service. And yeah, I already have discussed the three of these are the previews weeks, but the key trade-off is that as you move up the stack, you do less work, but you have less control. But if you move down, like in the infrastructure layer, you do more work, but you decide everything. So IaaS give you maximum flexibility, but requires maximum expertise. Like not anybody can do infrastructure as a service, but as for SaaS, like everybody can use the software. So it requires zero expertise, but you lock into what the vendor provides. And we already have discussed this as well on previous week, but IEEE identified four deployment models, and this is where practical decision happens. We got public cloud owned by third party. It's open to everyone via the internet, but it is less secure and you got less control. And we got private cloud owned by a single organization. It's internal, so it got like dedicated infrastructure. You got maximum security and you control everything, but it is very expensive and hard to maintain. Hybrid cloud is when you mix both. So you use private for sensitive data and you use public if there's like a non-critical work. And next one is community cloud. This is for shared multiple organization with common goals. It's like industry specific, like hospital, because they got like the same compliance requirements. And based on the 4 years of field deployment, IEEE documented five key benefits. And we have discussed it again in the past few weeks, but let's just go through again really quickly. So it's easy to manage, it reduces the cost, it is very reliable, and it got disaster recovery and green computing as well because you're using shared infrastructure. So it is more efficient and you got like less electronic waste. And IEEE was honest about the challenges as well. You got four challenges that um need to be discussed. But the thing is that for every challenges, it is actually very manageable if you just plan it like concurrently. So for security and privacy, you can plan like mitigation techniques to combat all these real challenges. So to summarize this, so InfoWord answered what? They gave us a functional definition and seven service categories. They showed us the landscape and flagged that it was still fragmented. But RIT answered how. They gave us a three-layer model showing how hardware, software, and data services stack into integrated infrastructure, and identified five distinguishing features and five enabling technologies. They gave us a theoretical framework, but IEEE answered where and why. They gave us a four-layer architecture and four deployment methods and documented real benefits and real challenges from 4 years of production use. So if you put them together, you get a complete framework. So the step one is you define what cloud is, what InfoWord does. And step two is organize how it works, at what RIT does. And step three is deployed in real world. That's what IEEE have done. So that's cloud computing from three expert perspective, or from the three articles that was discussed. Thank you.